Now we're going to talk about the effect of modifying an area on circles. If you recall from our last conversation, we talked about the fact that if I were to take a square or a rectangle and double it, so that means moving it twice in that direction and increasing it twice in that direction, the net result would be to increase the area by a factor of 2 squared, or 4. So my increased factor will be 4. When I talk about a circle, I only have one dimension to work with, really, and that's the radius. Remember, a circle is defined as the collection of points all equidistant from a given center, which means if I were to double the radius, that's effectively going to double all of that distances around. So it's like doubling the height and the width. So, in the case of a circle, if I increase the radius by a factor of 2, I'm going to increase the area by a factor of 2 squared, or a factor of 4. As a concrete example, let's take another one. I have a circle here of some unknown radius. Actually, let's give it a number. That radius is 10. I'm going to now modify the radius by a factor of 1/5. Means I'm going to shrink it down to 1/5 of its original size. So my new circle would be right there. Now, since the original radius was given as 10, multiplying that by 1/5 is effectively dropping my radius to 2. One method I could use is to calculate the area using 10, calculate the area using 2, and then see what the factor between them is. But there's an easier way. I can take the fact that I've modified the radius by a factor of 1/5 and say that my area will be modified by a factor of 1/5 squared, which is the same as saying 1/25. Now, if you doubt that rule, you can brute force it. My area with a radius of 10, pi r squared, is going to be pi times 100. If I do the same thing using a radius of 2, which is 1/5 of 10, I get pi times 4. Using that same formula of pi r squared. The result? My area drops by a factor of 25, as I expected. 314, which is what that would be if I turn it into a decimal, is 25 times larger than what I would get here, which is a number around slightly larger than 12. So again, I have that drop of a factor of 25. So again, I don't actually need to know any of these dimensions. I can use the idea that changing the dimensions of a circle's radius by a factor will change its area by a factor squared.